Okay, in this video we're going to have convergence for this power series here. So we apply the ratio test. I'll keep it in the screen. So the ratio test says examine the ratio of the n plus first term divided by the nth term. So my n plus first term looks like this, and the only thing that needs the absolute value is anything involving the x. So I'm going to put it around that expression. Okay, divided by the nth term, which I'm just going to think of as multiplying by the reciprocal of the nth term. And again, the only thing that needs a absolute value bar is is really the x, but I just put it around the whole 10x, and that's fine. Okay, so what cleans up here? This cancels with this, leaving one copy of 10x in absolute value. And that cancels and leaves an n plus 1 in the bottom, so that I end up with absolute value of 10x divided by n plus 1, right? Or I could say times 1 over n plus 1. Okay, now what the ratio test says is now take the limit as n goes to infinity of that expression. Okay, I usually like to take, anything that doesn't have an n in it, you're always welcome to just take out of the limit, and then you can just focus your attention on what's going on here. So hopefully, without too much thought, you realize that that equals 0, right? That limit equals 0. So you get that. Now 0 is less than 1 no matter what. So it doesn't matter what you plug in for x. You can plug anything in for x, and that ratio, the limit of the ratios will still go to 0. Because that 0 is coming from this here, right? It has nothing to do with the x. So you can put anything you want in there for x. Any number, there's no stopping this from becoming 0, which is less than 1. So any number works. If anything works, that means the interval of convergence is all real numbers. So our interval of convergence is negative infinity to infinity. And when that happens, you usually talk about your radius of convergence, if that's asked. You know, it's a kind of an abstract idea, but your radius of convergence is just half of that interval, which is infinity. So if we put this all in the sentence frame, you would say, you know, I applied the ratio test, and the interval of convergence I found before checking endpoints was negative infinity to infinity. When I plugged in the left endpoint, so there was no endpoint to check. So I'm looking down at my word bank now. No endpoint to check. And when I plugged in the left endpoint, I found, well, I guess there's two mistakes there, right? I should have said right endpoint. So there's a typo. But in any case, there was no endpoint to check. Therefore, my final interval of convergence is negative infinity to infinity, and my radius of convergence is infinity.